clarifies the query on the converter.
Okay.
And similarly for the third question,
Okay.
like, can an AC motor be run on? Is it necessary for an AC motor that is being used in actuator to have in having a AC power supply?
It is.
It
It is
is. It is
necessary. I mean,
necessary. I mean,
yeah, it is
yeah, it
necessary
is
that it should
necessary
be
that
an
it should
AC
be an
power
AC
source,
power source
because
because
not because
not because
it's an AC
it's
motor.
an
It should
AC
take
motor. It
only
should take
AC,
only
but
AC,
the
but
way it is
the way it
made,
is made,
it can only
it
take
can
AC
only
power
take
source.
AC power
So
source.
that is
So that is
how it should be.
how it should be.
Although,
Although
like,
like
nothing stops you
nothing
from
stops you
plugging
from
into
plugging
these
into these
into another
into
thing, but the
another thing, but
rated
the rated
current and this thing
current
will be
and this thing
different,
will be different,
and that
and
will
that
cause
will cause
problems,
problems,
causes of
causes of
heating
Uh,
or
heating or
improper mode of
improper mode of
operation, because your
operation,
DC
because your
power
DC
source
power source
will not have
will not
a
have a
fluctuating
fluctuating
it
uh,
won't be oscillating,
oscillating.
oscillate.
alternating.
It will
Yes,
not be an
it will not be
oscillating
an
EMF.
oscillating
So
EMF.
because of
So
that,
because of that,
you'll not be
you'll
able
not be
to
able
run a
to
DC
run a
motor on
DC
AC
motor
power,
on AC power,
right?
right?
Yeah.
Yes, yes,
So
yes,
Yeah.
stuff
yes.
like
So
that.
stuff
So
like that.
yeah,
So yeah,
these are
these are
simple
simple
questions, right?
questions, right?
I guess
I guess
Yeah, yeah,
you can
yeah.
sort
you
it out.
can sort it
Covering
out.
the basics. And sir, similarly, converting from DC power supply to AC, DC, for an AC motor, that is quite a relative to say how difficult, how is it is. So, can you please give some insight on how should we be understanding it?
I did
I
not
did
get
not
your
get your
question,
question,
Weber. Can
Weber.
you
Uh,
go
Can you
again?
go again?
Sir, third question, the
Yeah.
second part,
Yeah.
it goes as it is difficult to develop a power electronic converter that can convert DC power suitable to an AC motor. Now, here, difficult is quite a relative term, and it's getting quite hard for me to judge it. How should I be understanding it?
Even I'm
Even
not
I'm not
sure
sure
in what
in what
context this
context this
question is
question is
written.
written.
But
Yeah,
But
it's just that based on electric actuator, you have to justify whether it's true or false. You have to just comment on it. Is it true or false?
yeah,
yeah,
so
so
one thing
one
is
thing
that
is
your
that your
DC
DC
power
power
will not
will
be
not be
suitable to
suitable to
AC because
AC
it's
because
not
it's not
alternating,
alternating,
right?
right?
Yes.
So if
So
you
if you
Yes.
have a
have a
alternating
alternating
DC
DC
source which
source
is
which is
synchronous,
synchronous, which will be
not
synchronous, not
asynchronous,
asynchronous,
as
as
Yes.
compared to
compared
AC
to AC
motor, which
motor,
is
which
your
is your
BLDC
BLDC
motors,
motors,
right?
right?
Your
Your
BLDC
BLDC
motors, they
motors, they
work
work
similar to
similar
an
to an
asynchronous
asynchronous
AC
AC
motor,
motor,
three
three
phase
phase
induction
induction
motor.
motor,
But then
but
their
then their
supply,
supply,
power
power
supply,
supply,
and
and
way of
way of
commutating is
commutating is
different.
different.
It is
It is
similar to
similar to
induction, but
induction,
it
but
will
it
be
will
little
be
different,
little different,
right?
right?
So
So
yes,
yes,
Yes.
it
it
is
is
difficult.
difficult.
Yes, this
Yes,
is the
this is the
difficulty.
difficulty.
A
A
BLDC motor
BLDC
works
motor
just
works
like your
just like your
induction motor,
induction
right?
motor, right?
Yes. 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 Yes.
So
So
I
I
guess
guess
it must
it
be
must be
true.
true.
That's it.
That's it.
I mean,
I mean,
Yes.
if
It
this
if
clarifies.
they
if
write
they
Thank you, sir.
write
difficulty,
difficulty,
then
then
you
you
can
you
fit in
can
a
fit
lot
in a
of
lot
things.
of things.
So I
So
think it's
I think
true.
it's
Hmm.
true.
Okay.
Okay.
Yes. Thank you, sir.
Yeah.
Yeah.
So
So
which
which
screen
screen
is being
is being
shared?
shared?
Not yet,
Not
right?
yet, right?
Okay.
Yes. Not yet.
Let me
Let
share
me
my
share my
screen.
screen.
We'll
We'll
make a quick
make a quick
clarification.
clarification.
Sir,
Yeah,
Yeah,
Pranav. Hi,
Pranav.
Pranav.
Hi, Pranav.
sir, I have a doubt in week 4, sir.
Yeah, yeah.
Yeah, yeah.
I'm going to
I'm going
discuss
to
week
discuss
four
week
only.
four only.
Yeah, tell me,
Yeah, tell
Pranav.
me,
Go ahead.
Pranav. Go ahead.
Sir, can you just explain the concept of dexterity and how to calculate it?
Yeah, go ahead.
Yeah, go ahead.
Sir, can you just explain it, sir? I don't quite understand it.
Okay.
Okay.
Dexterity.
Dexterity.
You're asking
You're
about
asking about
dexterity, is
dexterity,
it?
is it?
Yes, sir, dexterity.
Okay.
Okay.
Even
Even
I'm not
I'm not
sure
sure
because
because I've
not
not
covered that.
covered that.
Uh,
Uh,
okay.
okay.
You do
You
one
do
thing.
one thing.
I'll give you
I'll
my
give you
mail
my mail
ID.
ID.
Right? Can
Right?
you
Can
just
you just
shoot me a
shoot me
mail
a
on
mail
that?
on that?
I've not covered
I've not
dexterity as
covered
yet.
Yes,
dexterity
sir,
as
sure,
yet.
sir.
I'll
I'll
mail you back.
mail you back. One second.
So last
last
time
time
we
we
had
had
arrived at a
arrived at a
different
different
formula
formula
for
for
transformation
transformation
matrix as
matrix as
compared to
compared to
what
what
was
was
performed
performed
in
in
the
the
lectures.
lectures.
So
So
here is a
here is a
clarification for
clarification
it.
for it.
Both the
Both the
formulas
formulas
hold true.
hold true.
They will
They will
work
work
in
in
cases
cases
we take them.
we take them.
Okay, so
Okay,
let
so
us
let
take
us take
per
per
entry of a
entry of a
DH
DH
table. So
table. So
now
now
there are
there are
two
two
ways of
ways of
writing a
writing a
DH
DH
entry.
entry.
One
One
is
is
we
we
have
have
I,
I,
AI,
AI,
alpha I,
alpha I,
theta I,
theta
di.
I, di.
This is one
This
way
is
of
one way
writing.
of writing.
There is
There is
another
another
way that
way that
preferably
preferably
most of
most
the
of the
earlier
earlier
literature used to
literature
write
used to write
is
is
AI
a
minus
I
1,
minus 1,
alpha I
alpha I
minus 1,
minus 1,
theta
theta
I,
I,
di.
di.
Now
Now
what's the
what's the
difference
difference
between
between
these
these
is
is
nothing but
nothing but
the way
the
you
way
see
you
them.
see them.
So
So
let's
let's
take
take
you have
you
one
have
frame
one frame
which
which
is
is
Z naught,
Z naught,
X naught,
X naught,
and
and
another one
another one is
Z1,
Z1,
X1.
X1.
Here you can
Here you
see
can
that
see that
this
this
has
has
a
a
skew
skew
axis
axis
rotation,
rotation,
screw
screw
axis
axis
rotation,
rotation,
or
or
you can
you
say
can
your
say your link
link axis
axis
rotation.
rotation.
So how
So
this
how this
goes is
goes is
that
that
one, this
one,
is
this is
theta 1.
theta 1.
So
So
your
your
first
first
entry will
entry
be
will be
here,
here,
but when
but
you
when you
take
take
for
for
alpha
alpha
A,
A,
now
now
here you will
here you
see
will
that
see that
this is
this is
nothing but
nothing
your
but your
alpha
alpha
1
1
rather than
rather
your
than your
alpha
alpha
2.
2.
So
So
your
your
first
first
entry will be
entry will be
something like
something like
this:
this:
I,
I,
AI,
AI,
alpha
alpha
I,
I,
theta
theta
I,
I,
di,
di,
right?
right?
So your
So your
first
first
entry will
entry
be
will be
something like
something like
this.
this. 1
1 second.
second.
Yeah,
Yeah,
theta I.
theta I.
No, this
No,
will
this
not be
will
your
not be your
alpha
alpha
1.
1.
Rather, it
Rather,
will
it
be
will be
alpha
alpha 2.
Yeah,
Yeah,
alpha 2,
alpha 2,
because
because
for your
for your
first
first
axis
axis,
you do
you
not
do
have
not have
anything that
anything that
requires. Yeah.
requires. Yeah.
So your
So your
first
first
thing will
thing
be
will be
0
0,
0.
0.
This will be
This will be
theta
theta
1,
1,
and
and
this will be
this will be
d1,
d1,
right?
right?
And
And
your
your
second
second
axis will
axis
be
will be
something like
something like
this.
this:
You will
you will
have
have
minus
minus
90
90
degree
degree
rotation.
rotation.
Okay,
Okay,
sorry.
sorry.
Let's take
Let's
this
take
is
this
a.
is A. Right?
So this
So
will
this
be
will be
A2.
A2.
Yeah,
Yeah,
here you
here
will
you will
have
have
0
0,
minus
minus
90
90
degree
degree
rotation.
rotation.
Here you will
Here you
have
will have
theta 2,
theta 2,
0,
0,
right?
right?
And your
And your
third
third
axis, which
axis,
will
which will
be
be
somewhere
somewhere
here,
here,
third
third
frame,
frame,
that will
that
be
will be
nothing but
nothing but
A2.
A2.
Let's
Let's just
mention it
mention it:
A2,
A2,
0,
0,
0, 0,
0, 0.
right?
Right?
This is
This
how
is how
your
your
axis will
axes
be
will
in
be in
this way
this
of
way of
putting it.
putting it.
Here,
Here,
this
this
entire row
entire
that
row
you
that you
see
see
will just
will
shift
just
up,
shift up,
right?
right?
So when
So
we
when we
have
have
such a
such a
notation,
notation,
our
our
here
here
again,
again,
how are
how
we
are we
going?
going? So
For
for
any
any
transformation that we
transformation
are
that we are
doing,
doing,
this
this
is
is
where
where
I had
I had
made
made
mistake
mistake
last
last
time.
time.
Is that
Is
when
that
we
when we
have
have a
zero
0
1
1
frame,
frame,
T01
T01
frame,
frame,
if I
if
have
I
to
have to
go to
go to T
2
2
frame,
frame,
I will
I will
multiply
multiply
the
the
transformation
transformation
matrix
matrix
adjacent to it,
adjacent to it,
and
and
so
so
on the
on the
sequence will
sequence
be
will be
T
T
n and
n
minus 1,
minus 1,
right?
right?
So this
So
will
this
give
will
me
give me
from
from T
T0 to
0
n.
to n.
So this
So this
is
is
how
how
my
my
transformation
transformation
matrix will
matrix
be
will be
considered.
considered.
So
So
now
now
there are
there are
two
two
such
such
formulas
formulas
for
for
transformation
transformation
matrix that
matrix
you
that
will
you will
find
find
online,
online,
and
and
generally
generally
one of
one
them
of
you will
them you will
find in
find in
old
old
books
books
here,
here
or
or
your
your
normal
normal
textbooks.
textbooks.
One
One
I'll
I'll
just
just
mention
mention
John
John
Craig.
Craig.
Um,
John
Craig.
Craig.
So in
So in
John
John
Craig,
Craig,
how they
how
have
they have
given is
given is
that
that
transformation
transformation
from
from
I
I
minus
minus
1
1
to
to
I
I
frame
frame
is
is
given by a
given by a
transformation that
transformation
is
that
in
is in
screw
screw
axis
axis that is ai minus 1 comma alpha I minus 1 times transformation in the link axis, that is z axis, that will be theta I di, right? So this will turn out to be ti minus 1 ti will be equal to 1 0 0 0 c alpha I minus 1 minus s alpha I minus 1 I minus 1 0 s alpha I minus 1 c alpha I minus 1 ai minus 1 0 0 0 0 0 1 times you will have c theta I minus s theta I 0 s theta I c theta I 0 0 0 1 0 0 0 1 0 0 ti, right? So this is one way of getting to your frame, and this is how it has been followed since the literature of robotics, and this is also a true way of reaching to a frame. Like, we first orient our link axis, we first orient our joint axis, right? This particular thing will orient it, and then we do operation about the joint axis, right? So there is another way of doing this jugglery, is that you have z axis, you do theta I di, then about x axis you do something called alpha I ai. So this will also result you in uh, a similar way, but in the end you will get both your transformation matrix to come out to the same, but intermediate step they will be different, but you are doing it correct. So that does not mean that it's going to give you a different answer in the end. So here we are just taking two different set of transformation to reach to a point. So that point, in this it is ahead, in this it is preceding. This is preceding, preceding, preceding. This is ahead, right? So yeah, so in this I minus 1 I, you will have a different formula that would be something like this: c theta I minus s theta I 0 0 s theta I c theta I 0 0 0 0 1 di 0 0 0 1, right? And here you will have the same, but ai c alpha I minus s alpha I 0 0 s alpha I c alpha I 0 0 0 0 1, right? So these both will take you from one frame to the other. These both of these formulas are available online, right? So they are the same, they are almost the same. Only thing you can see that what happens here is that you are going in an x z x z x z fashion, right, of your transformation. So if I take xz together like this, so this is nothing but my first one. Now if I have this xz, and first x is, generally it is not used, right? If I take this, so it's nothing but this one, right? So these are the two formulas that are online, but only one thing that we have done a mistake is that our multiplication will go this way, right? So I'll show you a particular case where we have taken this frame, and you can see that it works out perfectly. Okay. Okay.
So
So
here is
here
the
is
end
the end
effector,
effector,
right?
right?
So
So
this
this
is
is
nothing but
nothing but
A,
A,
D.
D.
So we'll
So
take
we'll take
this
this
case. I'll
case.
show
I'll
you
show
just
you
now.
just now.
So
So
in that
in that
we'll
we'll
get,
get,
even
even
using the
using the
first
first
formula which
formula
I
which
had
I had
shown,
shown,
cancel
cancel. Yeah.
this one.
This one.
Even
Even
this formula
this
is not
formula
in
is not
your
in your
lecture
lecture
module,
module,
right? This
right?
is
This
what they
is
have
what they
given
have
you,
given you,
right? You can
right? You
use
can
both.
use both.
Both of them
Both
will
of them
work.
will
I'll
work.
just
I'll
show
just
you.
show you.
I'll
I'll
be
be
switching my
switching my
screen.
screen.
Yeah.
Yeah.
Are you able
Are
to
you
see my
able to see
screen?
my screen?
Hello?
Hello.
Yeah,
Yeah.
Yeah.
So in
So
this,
in this,
I have
I
used the
have used
first
the
way of
first
doing
way
it.
of doing it.
The thing I
The
have
thing I have
defined is,
defined is,
you can
you
see
can
the
see the
transformation along,
transformation along,
right? So
right?
this
So
is
this
the,
is the, okay,
yeah,
yeah,
transformation
transformation
along
along
uh, joint
joint
axis,
axis,
right?
right?
And this
And
is
this is
transformation along
transformation along
formation
formation
along
along
link
link
axis.
axis.
Yeah.
Yeah.
And here
And
you can
here you
see
can
that I
see
have
that I
done
have done
screw
screw
axis
axis
times
times
link
link
axis
axis
here,
here,
right?
right?
Screw
Screw
times
times
link, sorry,
link,
joint
sorry,
axis.
joint axis.
Screw times
Screw
joint,
times joint.
link times
Link
joint,
times joint.
link
Link
times joint,
times joint.
right?
Right.
So here
So
you can
here
see
you can
that
see that
I have
I
gone
have
in
gone in
one
one
particular order.
particular order.
That
That
is,
is,
wait,
wait,
let me
let me
increase my
increase
font
my
size.
font size.
Yeah.
Yeah.
I guess
I
this is
guess this
better.
is better.
Yeah.
Yeah.
So here
So
you
here
can
you can
see my
see my
first
first
transformation that
transformation
I'm
that I'm
doing
doing
is
is
about
about
z
z
axis.
axis.
So which
So which
is,
is
okay.
okay.
Let me
Let me
also
also
share the
share the
screen
screen
so that
so
you
that
can.
you can know.
So yeah,
So yeah,
here you can
here you can
see
see
the
the
transformation.
transformation.
The
The
axis is
axis
how
is
we
how
are
we are
considering,
considering,
right?
right?
So
So
based on
based
that,
on that,
the
the
first
first
here
here
is
is
theta 1,
theta one,
right?
right?
So
So
this is
this is
theta 2,
theta two,
right?
right?
So here
So
you
here
can
you
see
can
the
see the
T1
T1
is
is
theta 1
theta one
that I've
that I've
taken
taken
here.
here.
You can
You
see
can
that
see that
I have
I have
formed a
formed a
transformation
transformation
matrix,
matrix,
and
and
all I'm
all
doing
I'm
is
doing is
substituting those
substituting those
transformation
transformation
matrix with
matrix with
the
the
entries that
entries
I
that I
want.
want.
So the
So the
first
first
one
one
will
will
have
have
alpha
alpha
A1 as
A1 as
0,
0,
but it
but
will
it
have
will have
D1 and
D1 and
theta 1.
theta 1.
So
So
here you
here
can
you
see
can
that
see
I'm
that
only
I'm only
substituting
substituting
for
for
theta
theta
1,
1,
right?
right?
So
So
from
from
here we
here
can
we
see
can
that.
see that.
Wait.
Wait, let me clear.
Yeah.
Yeah.
So
So Here we can see all the transformation matrix, and that way it will be clear for us, right? So this is the first transformation matrix that we will have. It will be rotating about z-axis, and it will be translating d1 distance in z-axis, right? So this is not much of a trouble, so it works all right. And here you can see that t12 uh, one our transformation our axis has rotated about x-axis 90 degrees. Here you can see, and then it has rotated about the new z-axis for theta 2 t2 degrees, and the third is a translation about the x-axis of the second frame, right? So here you can see that we are getting our forward kinematics a1 times cos of theta 1 cos theta 2, because one it has rotated in one axis here, in this axis. You can check my ipad screen. Yeah, about this axis it has rotated. So this one will make components. A will make cos theta 1 component in x, and a sin theta 1, yeah, sin theta 1 in y axis. And then because of another rotation, there will be again cos theta 2 that will be there, because okay, let us go reverse, so that way we'll understand. Now here, because of theta 2, this will have uh, let's take it is something like this. Here you can see this will be a sin theta 2, and this will be a cos theta 2. Since this has also rotated, a cos theta 2 will have two components, cos theta 1, a uh, yeah, cos theta 2 sin theta 1, right? Yes. And this one will get subtracted with d1, so d1 minus a sin theta 2. So here you can see that both this way you will get. The earlier way you were already getting, and in this way also you will be getting. So there is you just need to be careful about matrix multiplication, which order you go. So that order has to be clear, and I have made a mistake in that order last time. So yeah, with that I think this is clarified. There are two formulas for this, so don't worry about each of them. Right? Both of them will work. So let me come out of that. Yeah. Yeah. So this was the clarification in the previous chapter. It's a previous week, and this week mostly they have it's a straightforward question they have given. So based on the lecture material, you have to select choose your answers. Yeah. So yeah, is there any doubt from week 4 or week 3 maybe? Okay. Hey guys, am I audible? Too late to ask, but am I?
Yeah.
Yeah, Piyush, this is clear, right? The one that I have mentioned now. There are two formulas to it, so both of them are going to work. But only thing is that the order in which you have used your DH parameter has to be really clear.
Yeah.
Yeah. So this is what we have learned. Like when we learn from textbook, this is the method in which we have learned. But the formula that you have mentioned last time, it was new to me. But yes, so there was small mistakes that I have done. It is I minus 1. So we always take the here the a I minus 1 alpha I minus 1. This was not clear. This was something I overlooked. That was perhaps that caused the confusion. Yeah. Week 5, I guess the content is clear, right? It's a formula substitution that you'll have to do. You need to find torque, um, torque in an armature, and you have to find EMF based on how many turns it has made. So that will nothing be that will be minus d phi by dt. Your phi is nothing but your flux, right? So these are the two types of problem they have asked. There are numericals. They are pretty straightforward. So you can work them yourself, I guess. Yeah. So is there any other doubt? Pranav, I'll get back to you about dexterity. So probably I don't remember on top of my head. So let me just go through that, and you can post your question to me, Pranav. Okay? Just mail me that question, whatever question you have. Okay, Pranav? Yeah. Do you have any other doubts? I guess this is what I had for this week. Yeah. Okay. So we don't have any doubts. Pranav, are you there?
Sir,
Yeah.
sir, the dexterity question, can I ask you in the can I ask you in the mail or can you explain?
Yeah, you can ask in the mail because I'll have to see what is that dexterity. Yeah.
Okay.
Yeah, in the context of what it was carried out in the course, I'll have to refer that, right? So yeah. Okay. Okay. So we are at the end of it. So are you talking? Your mic is off. There is another mic, I guess. So I'm talking from that. Yeah, there are two screens that I'm logged into. So yeah. Okay. So this is all for this week. Maybe we had a small session this time. Is embedded C used in robotics? Yes, it is. It is used in microcontrollers. Whenever you have to it is easier to use embedded C because accessing a transistor from your microcontroller, it's a lot more easier when you have a application or a software package that is really bare metal, like it is interacting with your hardware directly. So yes, embedded C is used in those cases, right? How is it different from C is that your C is an application layer where it will make a machine level code. It's a compiler that will make a machine level code, and so that your machine understands. In embedded C, you have really more flexibility in converting into machine level code. You can directly use a register value, and then based on that register value, you can take parameters or values or embed values into it. So that way, it's used in robotics. Yes. Yeah. Okay. So we'll close the session for today. Although it was a short session, but then I guess upcoming weeks it will be little heavy, and we'll be able to discuss more. Right. And Pranav, I'll get back to you in the mail based on the dexterity, how they have explained in the lectures. Based on that, I'll get back to you. Okay.
Yes, sir. Any other doubt also, I will
Let
talk
me
to
know.
you in the mail, sir.
Yeah. Thank you, guys. So I'll close the session for now.
Thank you, sir.
Thank you.
Thank you, sir.